Let us go ahead and set up as well as validate Spark 1.6.x. Even though Cloudera support both Spark 1.6.x as well as Spark 2.3.x, we can only set up Spark 1.6.x with packages. To set up Spark 2.3.x, we have to first migrate our cluster from packages to parcels, which we'll be seeing very soon. That being said, to add Spark 1.6.x to the existing cluster, we can use Cloudera Manager, and it is very straightforward. You just have to expand this, click on Add Service. There are two items with respect to Spark. One is Spark and the other one is Spark Standalone. So Spark Standalone uses a different distributed resource management framework, which is nothing but standalone, which comes with Spark itself. However, this is not good for production scale clusters. It is good for development and testing purposes. For production scale clusters, either we use Yarn or Mesos for resource management. As we are going to use Yarn, we just have to select this and then click on continue. Once you hit on continue, it will actually ask you to configure the roles. As we have only Spark Job History server that needs to be configured with respect to Spark 1.6.x, we just have to choose the server on which Spark Job History server should be running. In this case, we will be choosing Big Data Server 4 because Big Data Server 2, 3 and 4 are categorized for deploying the masters, and Spark Job History Server is kind of a master component, and hence we are choosing one of them. And here I have made the choice of Big Data Server 4. In your environment, you have to follow your capacity planning and then you have to configure it. Then you can click on OK. When it comes to gateway, we have been configuring each and every node as gateway starting from HDFS, and Spark automatically chose all the servers as gateways, and hence I will leave it as is. But at least you need to choose the designated gateway nodes as gateways to run Spark jobs. Then I hit continue. There is nothing to be configured here at this time. If you want to securitize your access to job history server, you can take care of these additional steps. For now, we will defer it. Let's hit continue. And then let us review these 3 steps which is being executed to set up Spark service on the cluster. So first it is creating Spark user directory. So in HDFS, there will be a user space called /users/Spark. In that, it is actually creating a directory called application history, and that directory will be used by Spark Job History Server to provide you the information for the completed jobs. And then it is actually installing Spark Jar on service Spark so that the Job History Server will be deployed, and also it will be started automatically for you. Now you can hit on continue and then finish. It will take you to the dashboard. You have to just click on this and make sure to restart any stale services. As of now, there are no stale services, but as it actually pop up, let us just restart. There is no harm with this. It will redeploy the client configuration and also restart all the services. Once this is done, your Spark Job History Server will be up and running, and also the client configuration will be deployed on all the servers. Once that is done, we should be able to run Spark jobs on the cluster. Now everything is restarted. We just need to click on finish. Still, the Spark Job History Server is not started. Let us make sure it is started. I am clicking on the Spark service. As of now, History Server is stopped. We can click on actions and we can just say start. Now it is up. Let's click on close. And let us refresh this. It is still coming up. Let us wait until it is done. If you want to review the logs while it is running, you can connect to the gateway node, and then from that gateway node we can connect to the Big Data Server 4 on which Spark Job History Server is configured, and then you can say sudo su-root, go to where log Spark, and then you should be able to see the log file. You can open this log file and make sure that there are no errors. If there are no errors, most likely it should be up and running without any issues. So let us review again from the Cloudera Manager to make sure that it is up and running. So now History Server is up and running. Also, to run the Spark jobs, you need to make sure that Spark jar is installed. So if it is highlighted here, if it is failing, then we can click on this install Spark jar and it will take care of setting up the jar file on the cluster, and then we should be able to run the Spark jobs. However, we don't need to worry too much about it at this time. That being said, as Spark is added to the cluster, now it is time for us to run some Spark jobs and validate that everything is set up properly. We'll be using the gateway node to submit the Spark jobs. Let us make sure that we are on gateway node. Currently I am on the gateway node itself, so I'll be using this to actually submit the Spark jobs. That being said, Spark provides APIs as well as framework for distributed processing. Developers take care of developing Spark-based applications using those APIs with Scala or Python or Java as programming language. Once the development is done, they will release the code, and typically that is released in the form of jar file. When that code is released, it is the responsibility of developers to provide run guide for their applications, and we need to deploy on our cluster using some standard scheduling tools. As part of Spark setup, we get examples and they can be submitted using Spark submit command, so that as administrators, we just get hang out of how to submit Spark jobs once the developers provide the jar file. Let us review some of the arguments we can pass using Spark submit to control the runtime behavior of Spark application. And then we will first submit a job using Spark submit using the examples provided as part of the Spark setup. Let us review whether this jar file exists or not. So I'm copying and then pasting as part of ls-ltr, and you can see that the jar file exists. So we'll be using this to run Spark job in a moment. And the command which we'll be using is nothing but Spark submit. If you hit enter after typing Spark submit, it will actually show you several control arguments, and we have to use these things to submit the Spark jobs. Over a period of time, even administrators should have some amount of idea with respect to these control arguments. Let us review some of them. ---- master is used to tell which framework you should use to submit the jobs. When it comes to yarn clusters, we use ---- yarn. However, when we use distributions like Cloudera, yarn might be default. So even if you do not specify ---- master with yarn, it might take yarn itself as the default execution mode. That being said, on top of this, the next important property is ---- class. So when it comes to Java or Scala based applications, we have classes that are delivered as part of jars, and those classes can be Spark applications. So you need to identify the Spark application, and then we have to get the corresponding class for that Spark application, and we need to pass that as part of ---- class if it is Java or Scala based application delivered to you. And as part of the runtime guide, they will tell how to submit the Spark submit job directly. However, sometimes we might have to run just to play around, and you might have to explore additional control arguments that are not suggested by the developers, and hence as administrators we need to have idea about what are these control arguments and how we can use while running Spark submit command. Okay, and then if we have to pass any third party jars, we have to use ---- jars. We can also deliver jar files at runtime using internet if you know the repository on which the application is depending upon, and you can use ---- package for it. This information is typically provided by the developers only. Sometimes administrators have to figure out the appropriate jar file if developers are not able to identify the issue, and for that, understanding this ---- jars is a bit important. That being said, on top of master and class, another important property is ---- So there are certain properties which control the runtime behavior of your Spark cluster as well as Spark runtime of the jobs. To overwrite any properties while jobs are running, when job is submitted, we have to use ---- and we have to specify the property and then equal to and then value. We have seen this with -D with respect to Hadoop FS command earlier. ---- is similar to that. However, if you have bunch of properties and if you want to pass all those properties to be overridden at runtime, you can use ---- properties file and you can pass file, and that file should be in the form of spark defaults.conf, which we'll be seeing very soon. On top of these things, we need to pass the jar file so that the classes that are part of the jar file can be executed. Without the jar file, if you just pass class name, it doesn't know from where that class should be executed. And hence, after Spark submit, after passing all these control arguments in any order, we have to pass the jar file name. Whatever arguments your class takes, you have to pass those arguments after the jar file name. This is how a Spark submit command look like. You have Spark submit and then you have control arguments with values. You can pass these control arguments in any order. You can pass class first and then master and then conf, or in any order. And we will be having a handful of them in actual jobs. And that information is typically provided by developers. And then you have the jar file name and then the arguments which this program take. So here we are trying to run a program called Java word count. It takes only input path. Once the program is executed, it will actually print the output on the screen itself. So let us run this command. If it runs successfully, then we have been successful in setting up of Spark on our cluster. You can see that it is using Spark 1.6.0, which is the version we have configured at this time in the cluster, and then it started running. It will take a bit of time because we are trying to process 1 GB of data and trying to get word count. Now it actually got the resources to run the job. Now it is actually running. If you want to monitor when it is running, first you need to start SSTL, and then you can take this tracking URL which is provided to you when you submit this Spark job, go to browser and paste it here. Then you should be able to see the progress of your job while it is running. If the job is completed, it will get you the history of the job also. Now let us spend some time to understand this interface. You can see there is job information, stages, storage, environment, executors, etc. It will provide the information for the job that is running at this time as part of our Spark Submit. When we actually do Spark Submit, there can be multiple jobs. It will list all the jobs here. And then if you want to see how the resources are being allocated to the cluster to run this job, you can go to executors. For each and every job, it will actually create a Spark cluster. You can see it has created 10 executors. Out of them, 9 are primarily to process the data. 1 is for the driver. And this driver is on the gateway node on which we have submitted the job. And then if you want to get the runtime values of the properties, you can click on environment and you will be able to see all the properties that are being used at runtime by your job here. However, we will come back to this once we review the property files and properties so that you understand at least some of the information which is provided here. Once the job is completed, it will automatically take you to the job history server and you should be able to see this information even after completing the job. Now the job execution is done. The behavior of Java word count we have submitted here is nothing but to perform the word count and print the results here. As it has to print the results here, it will take some time to print everything. It has printed everything. Once that is done, it actually stopped the job and then it came out of the Spark Submit command. This is how you can actually run the Spark Submit command to validate that your cluster setup is successful. On top of Spark Submit, Spark also provides a couple of development tools. One is Spark Shell and the other one is PySpark. Spark Shell is primarily for Scala developers. If you are a Scala developer and if you want to explore Spark-based APIs using Scala REPL, you can launch Spark Shell directly. It will create something called Spark Context, and using that Spark Context, you can run code like this. Also, if you want to control runtime behavior when you run Spark Shell, you can use properties like this, such as master, conf, etc. However, class is not typical with Spark Shell. We will not be using class as part of Spark Shell because the code will be developed as part of the Spark Shell itself. If you are a Python developer, you can use PySpark to launch Python REPL or CLI, and also to create the object called as Spark Context. Again, you can use this Spark Context and you can actually explore the APIs to read the data, process it, and then write it back to HDFS or whatever file system you want to. However, tools like Spark Shell or PySpark should be used only in development process. They should not be used to run the code in production. If any developer is trying to run it, you have to control as an administrator. Otherwise, your cluster might run into manageability issues. That being said, we have successfully configured Spark 1.6.x in the cluster, and also we have ran a job using Spark Submit and saw that it have actually used multiple nodes in the cluster using Yarn as resource management tool. Now we'll actually deep dive into few more details to understand what is going on under the hood.